Privacy in Blockchain, a survey of cryptographic mechanisms in Monero. A blockchain is a distributed digital ledger maintained collectively by a network of independent computers called nodes. Instead of relying on a central authority to validate transactions, the network reaches consensus through cryptographic rules and protocol level verification. Data is stored in blocks linked cryptographically. Each block contains a list of validated transactions, a timestamp, and a cryptographic hash of the previous block. Once recorded, data cannot be removed or altered. This permanence means that privacy leaks are not temporary but persist indefinitely. Blockchain offers immutability, but is not absolutely immutable, only probabilistically immutable. In technical terms, being immutable is to not be able to be altered in the memory after its value is set initially, such as a constant. This is where privacy becomes a problem in blockchain technology. Public block explorers allow, or Public block explorers is a web-based search engine and a verification tool that allows users to view, track, and analyze data recorded on a public blockchain network. Individuals transacting with digital assets risk leakage of financial behavior and identity. One way to enhance transaction privacy is with Monero. Monero is a privacy-focused cryptocurrency designed to provide secure, private, and untraceable transactions. Its privacy model prevents observers from determining sender, receiver, or transaction amount. It uses a decentralized blockchain without reliance on central authorities or intermediaries. Wallets control visibility of transaction data and can share view-only access when desired. Miners validate blocks approximately every 2 minutes and receive block rewards. Transactions transform inputs into outputs with only the wallet owner knowing which outputs belong to them. In order to achieve private transactions, Monero also uses stealth addresses, ring signatures, ring confidential transactions, covert, and elliptic curve cryptography. To begin, let's start with stealth addresses. In Monero, each transaction generates a one-time public key called a stealth address. Stealth addresses prevent outside observers from knowing the receiving address. The stealth address is visible on chain but cannot be linked to the receiver's actual wallet address. Only the receiver, using their private view key, can detect outputs intended for them. Stealth addresses prevent reuse and blocks attempts to map wallet identities. Stealth addresses verify payments through a cryptographic process where the recipient uses a private viewing key to scan the blockchain and identify transactions destined for them without revealing their identity. Ring signatures. Now, ring signatures obscure the sender. They do this by combining the real input with decoy inputs from past transactions into what they call a ring. All inputs in the ring appear equally plausible as the true spender. The actual signer uses a one-time spin key, while decoys provide anonymity. Observers cannot determine which input in the ring is genuine, which protects sender anonymity. Ring signatures also use key images to ensure that each output can only be spent once without revealing the input creating the image. Without revealing which input created the image. Key images are cryptographic constructs used in linkable ring signatures to prevent double spending, while maintaining the anonymity of the signer. In systems like Monero, a key image is a unique value derived from the private key and the public key of the output being spent. Ring confidential transactions, or Ring CT. Monero activated Ring confidential transactions, or Ring CT, in January 2017. It became mandatory, in September of 2017. Now, when Monero is transferred for the first time, Ring CT is masked with how can I say this? Ring CT with masked amounts are generated. Ring CT conceals transaction amounts and prevents privacy leaks by hiding the transaction amounts in the blockchain while still allowing the network to verify validity. Now, inputs must be the same as outputs. An account must essentially commit to the amount of an output and just enough information for the network to confirm the transaction. Miners are also able to confirm the amount of Monero being sent to accounts is the same as the amount of funds available. This helps prevent double spending and fraud. Double spending is a potential vulnerability in digital currency systems where a user attempts to spend the same amount of cryptocurrency more than once. An important aspect of Ring confidential transaction to know is the range proof. The range proof prevents senders from committing negative values to secure a supply of Monero. It cryptographically proves the amount used in a transaction is greater than zero and less than some arbitrary number. With the help of range proofs, Ring CT prevents external observers from inferring financial behavior from things such as transaction history. This would allow external analysts to link transactions, estimate user wealth, or infer spending patterns based on transaction amounts and sizes. Covert. Covert is an anonymity layer based on the Invisible Internet Project, or I2P, that hides network-level metadata in order to cloak IP addresses. Covert routes traffic using garlic routing. Garlic routing is an anonymous communication protocol used by I2P that extends onion routing by bundling multiple messages called cloves into a single encrypted packet known as a garlic. This bundling mechanism enhances privacy by making traffic analysis more difficult, as it obscures the relationship between individual senders and recipients through message aggregation and padding. Covert ensures that nodes cannot see the origin IP address of a transaction broadcast. Very important. This prevents adversaries from linking transactions to physical locations or network identities. This also protects users from network surveillance and targeted attacks by malicious nodes. Overall, no one will know your physical location or network address or network identities, network address, if you use Monero. Now, elliptic curve cryptography in Monero. Elliptic curve cryptography is used in Monero for key generation, signatures, and commitments. The elliptic curve discrete algorithm problem, Q equals K times P, determines an unknown integer, K, given a base point, P, and a resulting point, Q, on an elliptic curve, where Q equals K times P. The standard curve equation is y squared equals x cubed plus ax plus b over a finite field. A finite field is a mathematical structure consisting of a finite number of elements on which the operations of addition, subtraction, multiplication, and division, excluding division by zero, are defined and satisfy the standard field axioms. The order or number of elements of a finite field is always a prime number or a power of a prime. ECC has smaller key sizes compared to RSA. For example, in ECC, 256-bit encryption strength is equivalent to 3072 bits in RSA. And then going up a notch, government top secret level encryption in ECC is only 384 bits compared to RSA at the top secret level being 7,680 bits. Lastly, Shor's algorithm can solve the elliptic curve discrete logarithm problem more efficiently than it can factor large RSA integers. So a sufficiently powerful quantum computer could potentially derive private keys from public keys, compromising Monero's cryptographic foundations, which I'm eager to see in the future. Um, Overall, in conclusion, what we went over is that blockchain is a decentralized public digital ledger where data is stored in blocks linked cryptographically in a probabilistic immutable way. We also learned that Monero is a cryptocurrency designed to provide secure, private, and untraceable transactions by using stealth addresses, ring signatures, ring confidential transactions, or ring CT, covert, and elliptic curve cryptography. Stealth addresses prevent outside observers from knowing the receiving address and ensuring transactions are private and untraceable. Ring signatures obscure the sender with decoy inputs made up of a ring of Monero accounts. Ring confidential transactions conceal the amount of Monero that's transmitted by ensuring inputs and outputs balance, along with range proofs that prevents external observers from inferring financial behavior from your transaction history. Covert is an anonymity layer based on I2P that cloaks IP addresses with the use of garlic routing. Finally, elliptic curve cryptography is used for key generation, signatures, and commitments. My final note, with all that being said, is, and this may be far-fetched, but I wonder if the emergence of Mythos will accelerate the timeline of strategic behavior among technologically capable adversaries regarding quantum computing. This would directly affect Monero since ECC is susceptible to Shor's algorithm. I'm eager to see this. I don't know if that will actually get people trying to get to or boost their quantum computing capabilities. But I'm eager to see, and I'm also eager to see if Monero has a post quantum computing solution for this. I'm eager to see. But overall, thank you for watching.